You've probably seen the headlines lately, right? I mean, everywhere you look, psychedelics are being hailed as this massive potential breakthrough for things like depression, anxiety, addiction.
Yeah, the hype is everywhere.
Yeah.
It's definitely having a moment.
It really is. But, if someone actually stopped you on the street and asked you how they work in the brain, like physically, what would you even say?
Most people would probably just say, it alters your chemistry or something vague.
Exactly. And that's what we are getting into today. Welcome to the deep dive. We've got a seriously incredible stack of sources today.
Oh, this one is a monster.
It is. We are looking at a groundbreaking April 2026 paper from Nature Medicine. It's by an international consortium GERN, BizDoc, and a huge team, and it's titled An International Mega-Analysis of Psychedelic Drug Effects on Brain Circuit Function.
Yeah, and that word mega-analysis is, well, it's not used lightly here.
Not at all. Our mission today is to meticulously unpack this entire concept. Basically, concept by concept, leaving absolutely no detail behind. We are going to map the definitive neural fingerprint of the psychedelic state.
Which is something the scientific community has been trying to do for decades.
Right. So, okay, let's unpack this. Because the paper talks about this psychedelic winter. What was that, and how did we actually get to this new era of neuroscience?
Well, the historical context is really fascinating. After a ton of initial research in the mid-20th century, there was this research winter, just a half century, where due to really strict regulatory schedules, rigorous neurobiological research on these compounds was totally frozen.
Like legally impossible to do.
Exactly. But now, the thaw is in full swing. If you go on clinicaltrials.gov today, there are over 400 active trials testing these compounds.
Over 400, wow. And to be clear, we're talking about a specific group of drugs here, right?
Yeah, the paper focuses on the core mechanism uniting what we can call the classic four.
So just to give you guys listening a mental grouping, the classic four are psilocybin, which is magic mushrooms, LSD, mescaline, which comes from certain cacti, and DMT, the central ingredient on ayahuasca.
Right. And what unites them isn't where they come from. It's that they are all 5-HT2A receptor agonists. They act like these master keys binding to specific serotonin receptors, particularly the ones on the apical dendrites of layer 5 pyramidal neurons in the cortex.
Okay, getting a little technical, but basically they hit the exact same lock in the brain.
Exactly. But here is the massive problem the paper points out. Despite knowing the exact receptor they hit, the brain imaging studies, specifically resting state fMRI, have been a total contradictory mess.
Yeah, I saw this in the text and it blew my mind. You have world-class labs studying the exact same biological mechanism but getting totally opposite maps of the brain.
It's like the classic parable of the blind man and the elephant. Right.
Oh, I love that analogy. Like, one researcher feels the trunk and says, oh, the brain on psychedelics increases global functional connectivity, and another lab feels the leg and says, no, global connectivity completely plummets.
Right, and this raises an important question. Why the contradictions? The researchers identify this as a problem of researcher degrees of freedom.
What does that actually mean in practice?
So when someone is in an fMRI scanner, the raw BOLD signal, the blood oxygen level dependent signal, is incredibly noisy. If the person's heart rate changes, or they take a deep breath, or they move their head a millimeter,
it scrambles the data.
Totally. So researchers have to choose how to clean that data. Do you apply a global signal regression filter? What's your threshold for head movement?
So every lab is just making different subjective choices.
Yes, and when you combine those different choices with the fact that these studies are wildly expensive, you get tiny sample sizes, like maybe 15 or 20 people.
Oh, wow. So small samples plus different data filters equals statistical chaos.
Exactly. You get a fragmented map where every lab is basically looking at the brain through their own custom-made pair of glasses.
Okay, let's take a quick pause here to recap for you guys listening. First, classic psychedelics work via that 5-HT2A receptor. Second, past fMRI research was just a fragmented mess because of those small samples and different analysis methods. And third, we desperately needed a unified standard. So, if every lab uses a different ruler, how do you measure the brain? Enter the mega-analysis.
Yeah, and the scale of what they did to fix this is just, it's monumental.
Right, so 11 independent data sets, 5 countries, 3 continents, 270 participants, and over 550 connectomes, which are basically these complete brain maps.
And the key is that they took all that hoarded data and ran it through a single uniform preprocessing pipeline.
They forced everyone's data through the exact same pair of glasses.
Precisely. But just cleaning the data wasn't the real breakthrough. It's the statistical shift they made. The paper emphasizes this transition from traditional frequentist statistics to a Bayesian hierarchical modeling framework.
Okay, you have to break this down for us, because I know most medical research uses that frequentist approach, right? The whole p-value thing.
Right. Think of a traditional frequentist approach like a bouncer at a club checking IDs.
Okay.
The bouncer only asks a binary yes or no question. Is there a difference between the drug and the placebo? Yes or no? If your p-value is under 0.05, you get into the club. If it's 0.06, you're rejected.
The bouncer doesn't care if you're 21 in a single day or if you're 65. It's just a hard line.
Exactly. It throws away so much nuance. But a Bayesian approach, that's more like a detective building a probabilistic profile.
I like that. A detective.
Yeah, the detective doesn't ask yes or no. The detective looks at all the evidence and asks, how certain are we that this effect exists, and how strong is it? It creates what are called posterior distributions.
Right, these visual curves I'm seeing in the paper.
Yes, they show the literal shape of uncertainty. A tall, narrow curve means the detective is highly confident. A wide, flat curve means the evidence is messy and uncertain.
Oh, wow. Okay, aha. So we aren't just crossing these arbitrary statistical thresholds anymore. We are creating a literal map of confidence.
Exactly. And because it's a hierarchical model, it borrows strength across all 11 of those data sets to figure out what's really happening.
Okay, time for another quick recap. 1, the mega-analysis combined 11 data sets to fix that whole different rulers problem. 2, they used Bayesian statistics, the detective, to measure the certainty and strength of brain changes instead of just a binary yes or no. So here's the big question for you. When we put all this data into the Bayesian detectives file, what is the ultimate signature it reveals?
This is where we get into the physical mechanics of altered consciousness. To understand the brain on these drugs, we have to talk about how the brain's networks are organized.
Right. Let's translate the neurojargon here. What is the brain actually doing? The paper talks heavily about transmodal and unimodal networks.
Yeah, so think of the brain like a massive corporate hierarchy. It uses predictive coding to save energy.
Okay, so who is at the top of the ladder?
At the top, you have the transmodal networks. This includes the default mode network, the frontoparietal, the limbic systems. These are the CEO and the executive board.
Got it.
They handle high-level abstract thought, self-reflection, your sense of ego, and they generate predictions about the world based on your past experiences.
Okay, so if they are the executives in the top floor corner office, who are the unimodal networks?
Those are the frontline workers on the factory floor, the visual cortex, the somatomotor cortex. They handle the raw, incoming sensory data from your eyes, your ears, your skin.
And normally, I'm guessing the CEO doesn't talk directly to the guy on the assembly line?
Right. In a sober state, sensory information is heavily filtered and compressed as it moves up the chain of command. The executives rarely deal with raw data. They just send down predictions to dictate how that data should be interpreted.
But here's where it gets really interesting. When they ran this massive Bayesian model, they found a huge, highly consistent increase in functional connectivity between these two groups.
Yes. If we connect this to the bigger picture, the defining action of psychedelics is what they call hierarchical relaxation.
Hierarchical relaxation.
Exactly. The strict, top-down control of the executive board is totally relaxed. The walls of that top floor office dissolve, and the CEO walks right down onto the factory floor.
So the raw sensory data is just mixing freely with high-level abstract thought?
Yes, and that maps perfectly onto a trip, right? When the executives are flooded with unfiltered sensory input, you get things like synesthesia seeing sounds or ego dissolution because the default mode network is overwhelmed by the present moment instead of its usual internal monologue.
That makes so much sense. But we can't skip over the deeper structures here because the paper makes a big point about subcortical secrets. They mapped the thalamus, the caudate, the putamen, the cerebellum.
Oh, absolutely. The cortex isn't acting alone here. Those deep brain structures are essentially relay stations. The thalamus, for example, is the grand central station of the brain. Almost all sensory data routes through it before it hits the factory floor.
And the model showed that these deep stations also had altered coupling with the sensory motor networks. So it's not just a surface-level cortical thing. The routing of reality itself is changing from the ground up.
Yes. The entire architecture of the brain is participating in this hierarchical relaxation.
All right, let's lock that in with a recap. 1, transmodal executives and unimodal frontline networks dramatically increase their communication. 2, this creates hierarchical relaxation, breaking down the brain's rigid filtering. And 3, deep brain structures like the thalamus get in on the action too. So we know the networks are talking to each other way more, but what happens within the networks themselves? Do they just fall apart?
This is a crucial point because earlier single-site studies, the ones with small samples, actually claimed exactly that. They pushed this idea of within-network disintegration.
Okay, I remember reading that years ago, that your brain networks just completely fragment internally on psychedelic.
Yeah, the narrative was that the boardroom literally implodes. But this mega-analysis proves that's a myth, or at least wildly overstated.
Really? So what did the Bayesian detective actually find?
When you look across all 550 connectomes, the model showed only weak to moderate, highly selective reductions in within-network connectivity. They absolutely do not fall apart. The internal coherence is mostly maintained.
So the boardroom doesn't implode, it just opens its doors to the rest of the company.
Exactly. The definitive signature is hyperconnectivity across boundaries, not internal collapse.
Wow, okay. I want to look at the specific rap sheet for each drug because the paper gives us these amazing posterior distribution charts for the classic four. Let's start with psilocybin and LSD.
I like to call them the twins.
The twins, yeah.
They had the largest sample sizes in the data, over 100 participants each. Because of that, the Bayesian detective was incredibly confident. Their curves are super tight, showing virtually identical network-level alterations. They reliably dissolve those boardroom walls.
Okay, what about mescaline? Because it's a bit different chemically, right?
It is. It's broadly similar to the twins in terms of that transmodal-unimodal bridging, but it showed more selective enhancements in integrating the cortex with those deep subcortical regions we mentioned earlier.
Ah, so maybe hitting the relay station's a bit harder.
Yeah, likely due to its specific pharmacological profile.
Now we get to DMT, which is famous for being like the most intense alternate dimension type of trip. But the Bayesian curves for DMT here are super wide and flat. The uncertainty's huge. Why?
Sample size. Pure and simple.
Ah.
They only had 16 participants for DMT. When you have high individual variability, like how fast someone metabolizes the drug, and only 16 people, the statistical dispersion is massive. The detective is basically saying, I don't have enough clues yet to be certain.
That makes sense. And ayahuasca is even wilder, right? Because it's not just DMT.
Right. Ayahuasca is highly idiosyncratic. It's a complex brew. It has DMT, but it also has MAOIs, monoamine oxidase inhibitors, which stop your gut from destroying the DMT.
And the sample size was what, like 9 people?
Just 9. And interestingly, instead of the classic bridging we saw with the others, ayahuasca showed reduced connectivity across the board.
Wait, really? The exact opposite?
Yeah. But with an N of 9 and the fact that MAOIs flood the brain with ambient serotonin and dopamine on top of the DMT, we just can't say if that reversed signature is real or just a statistical artifact of a tiny study.
We just need bigger studies for the botanical brews to really know for sure.
Exactly. We need to reduce that statistical uncertainty.
Let's do our final mini recap. 1, networks don't totally disintegrate internally. That was a myth from older, smaller studies. 2, LSD and psilocybin have nearly identical brain signatures. And 3, ayahuasca and DMT are still a bit of a statistical mystery because we need way bigger sample sizes.
Perfect summary.
So as we wrap up, what is the ultimate so what here? I mean, mapping a trip is cool, but why does this Nature medicine paper actually matter in the real world?
It matters because this establishes the reproducible, data-driven cornerstone for the future of precision medicine.
Precision medicine for psychiatry, you mean?
Yes. Think about severe, rigid psychiatric conditions, depression, OCD, addiction. In those disorders, the transmodal executive networks are hyper-dominant. They are inflexible.
Like a micromanaging CEO who refuses to listen to anyone else and just runs the company into the ground with negative thought loops.
Precisely. They are totally disconnected from the raw reality of the factory floor. If we know exactly how the 5-HT2A receptor forces that rigid hierarchy to relax, we can actually personalize treatments. We can benchmark how well a therapy is breaking down that rigidity.
So we aren't just giving people a chemical experience, we are doing targeted neural recalibration.
Exactly. It's a fundamental shift in how we treat the brain.
That is just incredible. And, you know, it leads me to this thought I want to leave you, the listener, with today. Think about your own mind when you are stressed or anxious or just stuck in a rut.
We've all been there.
Right. Your brain's executives are up in that corner office, micromanaging everything, obsessing over the past or the future, and completely blocking out the raw beauty of the frontline senses in the present moment. If a chemical like psilocybin can temporarily relax that rigid corporate structure in the brain, what daily habits or therapies or experiences might you use to induce a little bit of that hierarchical relaxation on your own?
Oh, that's a great question. Like breath work or flow states?
Exactly. Engaging in deep meditation or just radically changing your environment. How can you coax your own inner executives out of the boardroom and onto the factory floor today?
I love that.
Something to mull over. Thank you guys so much for braving these dense statistical waters with us today. It was a heavy one, but totally worth it.
Absolute.
Catch you on the next deep dive.